This video goes over question 11 of the Working with Lines homework. At sea level, the weight of the atmosphere exerts a pressure of 14.7 pounds per square inch, commonly referred to as 1 atmosphere of pressure. As an object descends in water, pressure P and depth D are linearly related. In salt water, the pressure at a depth of 33 feet is 2 atmospheres, or 29.4 pounds per square inch. So I'm going to make 2 points here. So I'm going to say 0 feet, so this is depth, and we'll abbreviate that DE. And then the pressure is 14.7, and I'm going to abbreviate that as PSI for pounds per square inch. So I'm going to call this depth 1, pressure 1. And the other point we're given is that at 33 feet, we're at 29.4 PSI. So that's D2, P2. I'm going to do this entire problem in the calculator. So I'm going to go grab the calculator, do split screen on that, bring up the work we just did, go split screen on that, or bring up the calculator. Okay, so I'm in a problem, but I'm going to start a new problem. Doc, 4 for insert, 1 for problem, and I want a list and spreadsheet page. Tab to get to the top, and I'm going to call that DE for depth. And my first depth is 0 feet, my second depth is 33 feet. Go over the next column, tab to get to the top. I'm going to call that PSI for pounds per square inch. So that's 14.7 and then 29.4. Control plus page, and I want a data and statistics page. My horizontal variable is going to be depth. My vertical variable is going to be pounds per square inch. Menu, 4 for analyze, 6 for regression, and the problem told us this was going to be a linear relationship. So there's my regression equation, and that matches D. So we'll go to this page here, D, check answer, fantastic. Choose the correct interpretation of the slope of the model below. It is the rate of change of pressure with respect to depth in units of pounds per square inch per foot. That is the correct one. So we only get one chance on that. Nice work. What is the pressure at a depth of 50 feet? So I'm going to go to a calculator page, and I'm going to hit var. And I've got the 2 things that I put in my list, the depth and the PSI. But the calculator has calculated all these other things when we did the regression. So this one thing here is a function. It says stat point reg equin. That stands for regression equation. I'm going to put an X in the parentheses there and hit enter. So that's my regression equation. I'm going to up arrow to highlight that, then go Control C to copy it, Control plus page, and add a graph page. Then I'm going to paste that in. I need to hit enter to put it in. Now I don't see anything, and I can fix my window later, but I'm just going to go back to my calculator page, and now I have F1, and I want to know what is the pressure at 50 feet, so I'm going to put in 50 feet, hit enter, and I want to round to the nearest pounds per inch per square inch, so that's 37. 37, check answer, well done. What is the depth at which the pressure is 4 atmospheres? So we know that each atmosphere is 14.7 pounds per square inch. So 4 times 14.7 gives me my target pressure. I'm now going to use solve. Menu, 3 for algebra, 1 for solve. Go back and get my F1 of x. So F1 of x equals, go up arrow and hit enter to bring that down, 58.8 PSI, and I'm solving for x. So that gives me the depth is 99 feet. So check answer, fantastic. And before we move on to the next question, I'm going to show you could do that in the graph as well. So I'm going to go on to the graph page, hit tab to open F2, and I'm going to put in 4 times 14.7. Okay, and I don't see anything, so I'm going to have to change my window. Menu, 4 for window zoom, 1 for window settings. So my X is going to be the depth. So I'm going to go -10 to 120 for depth and put a tick mark every 10. And I'm going to go -5 to, say, 60 for pounds per square inch. Tick mark every 5. And now I do see an intersection. Menu, 6 for analyzed graph, 4 for intersection, lower bound, upper bound, and I get 99 feet for 58.8 psi. That concludes this video.